All right, welcome back. Today we're going to go over how changing moles affects your delta H. So it's kind of an extension of what we've done before. So to do this, you're going to need this worksheet, determining the heat of the reaction. And you're going to also need your table I, your reference tables. So let's take a look at this, and we'll use a first example to kind of walk you through it, and then you can try some of these on your own. So number one, N2 plus O2 makes 2NO. So let's find this reaction on table I and look up our delta H. So we go to table I and we see our delta H is positive 182.6 kilojoules. That's right over here. All right, so remember what that means. That's telling us that we're dealing with an endothermic reaction. Energy is entering. So if the energy is entering, remember how we incorporate that into the equation. It enters the equation, so we're going to put that on the left. Right? So positive 182.6 means we're gaining energy, so the energy is entering the equation, it goes on the left. Now, just like any other time, when we change the amount of substances involved, it affects everything else proportionally. So that was stoichiometry. So this is just an extension of that. You treat the energy just like any other part in the reaction. So let's say I use 3 moles of N2 instead of the original amount. So the original amount was 1. So what if I use 3 moles instead of 1? How does that affect my delta H? So it's just like stoichiometry. So 3 over 1 equals X over your delta H. And you can think of it as new moles over old moles equals X over your delta H. That's a good way to look at it. So you cross multiply and you get 547.8 kilojoules. So your delta H is now positive 547.8 kilojoules. Notice your sign didn't change. It's still endothermic. We're still gaining energy. We just gained more energy because we're using more reactant. It's proportional. So make sure your numbers make sense. So like the second one, if I'm only using 0.25 moles of oxygen instead of 1, then what's my new delta H? So again, make sure it makes sense. If I'm using less reactant, I'm not going to consume as much energy. So I should get a smaller value for my delta H. And I do. I get positive 45.65 kilojoules. And now the last one, C, 2 moles of NO, 2 moles of NO. It's not changing. So your delta H is staying the same. We didn't change our amounts, so it doesn't affect anything. So let's look at number 2 here. Find your delta H off table I, look up the reaction, and you see that your delta H is negative 3351 kilojoules. So negative means exo. Energy is exiting. So we express that by showing the energy exiting the equation on the right-hand side. But notice it's added in. We're always adding in an equation. All the sign shows us is which side of the reaction the energy goes on. Endo, energy enters. It's on the left, the reactant side. Exo, energy exits. It's on the right, the product side. So next up, let's look at our things changing affects the delta H. So A, if 5 moles are used instead of 4. So aluminum, here's my aluminum. If I use 5 moles instead of 4, how does that affect my delta H? So 5 over 4 equals X over your delta H. You can put the negative sign in, or if you don't, just remember to put it back in when you're done, because the sign's not going to change. And we get negative 4,188.75 kilojoules. That's it. And again, make sure that makes sense. We're using more reactant, so we're going to generate more energy. So now take a few minutes and do the remainder of these problems, and also go on and do 3 as well. And we'll meet back in a few minutes and go over the answers. All right, so let's go over these quick. For letter B on number 2, we're using half a mole of aluminum oxide. So it's 0.5 instead of 2. How much energy is going to be produced? So there you go. Same thing with number C. If we're using 1 mole of oxygen instead of 3, what's my delta H over my original? Number 3, here's our delta H, negative 2219.2 kilojoules. So that means it's exo, energy's exiting, it gets added into the right. And then here's how changing these values affect our delta H proportion. So remember, this is just an extension of stoichiometry. Treat the energy just like any other part of the chemical reaction. If you adjust something, that affects everything else proportionally. And that's it for this lesson.